When trying to figure out which one of the molecules that are in green are polar, there are several steps you should take into account. The first thing you should do is draw the Lewis dot structures in order to figure out how many domains are in each molecule. The second thing you should do is figure out what the molecular shape is, so that way you can see if there's an electron domain or if it's just a bond. And the next thing you should do is draw the dipoles, and then from there you should be able to calculate the net dipole to see if it's polar or nonpolar. So as I said, the first thing you're going to want to do is draw the Lewis dot structure. So the one we're going to be doing is the one in red. So the first thing you're going to want to do to draw the structure is find out how many valence electrons are going to be in it. In this case, we know we have 4 chlorine and 1 carbon. When you look at your periodic table, each chlorine has 7 valence electrons and each carbon has 4. So when you do 7 times 4 plus 4, you end up with 32. So we know there's going to be 32 electrons in the Lewis dot structure. So the first thing you're going to want to do after that is draw your bonds between, and each bond is going to be equal to 2 electrons. So 2, 4, 6, 8. From there you're going to want to make octets in all of the chlorines. So 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Now since our original number was 32 and everything has an octet, you're done with this Lewis dot structure. After drawing the Lewis dot structure, the next step is to figure out the partial charge on each element. The easiest way to do that is to compare the element's electronegativity. In this case, oxygen's is 3.5 and sulfur's is 2.5. So it means oxygen is more negative, so in comparison it'll have a partial negative charge, and where sulfur will have a partial positive charge. It's the same way for each oxygen to sulfur, so these two both are negative while this one stays positive. Moving on to this one, when you compare fluorine to oxygen, fluorine has a 4.0 electronegativity while oxygen still has a 3.5. So the negative one in this case is fluorine while the positive one is oxygen. Doing it again between chlorine and beryllium, we find that chlorine has a electronegativity of 3.0 while beryllium has one of 1.5. So this one is negative, this one is positive, and this one is negative. Going on to the comparison between chlorine and carbon, chlorine has an electronegativity of 3.0 again, and carbon has 2.5. So chlorine is our more negative one, while carbon is the positive. Lastly, when we compare oxygen to oxygen, everything has a partial negative charge. Because they're all equal, though, it ends up canceling out and everything's pretty even. So that's the partial charges on each one of these molecules. So the next step is to draw the dipoles. Now, all the red elements are going to be the negative partial charges and all the blue ones are going to be the positive one. So we know dipoles go from positive to negative, so on this one it goes from here to there, again, and one more. So those are the dipoles on that one. Moving on, same thing, red is our negative and blue is our positive partial charge. So it goes this way and this way. Going again. And last one. Okay, so this one, because we had no partial charges because they were all equal, it has no dipoles. So figuring out if something is polar or nonpolar is to figure out the net dipole. Now in this case, for ease of convenience, we took dipole and moved it over here. So when looking at this one, we have 3 identical domains. And since it's a 3 domain and they're all identical, this means this one's going to be nonpolar because all of our domains will cancel out. So these 2 will cancel out going downwards with this one, going upwards, and also sideways, where these 2 will cancel out the horizontal movement. Moving on to this one, our 2 dipoles are on the sides, but we also had 2 unbonded electron pairs, which gives us 2 more domains, so it's a total of 4 domains in this one. And since at least one of them is different from the others, it means that this one's going to be polar. Moving on to the next one, we take our 2 dipoles, move it over, and seeing as how we had no unbonded pairs, this one's going to be nonpolar because our 2 domains, our dipoles, will cancel each other out. Looking at this one, we have 4 domains and all of them are equal, and since they're all equal in this one, it's nonpolar because they each cancel each other out. Lastly, we look at this one, and since we have 3 domains, we have to look at it in a dipole, even though they were all equal in partial charges. And since we had 1 pair of unbonded electrons, it means this one's also going to be polar because our 3 domains are not equal. So after going through all the steps and we look back at the original molecules, we know that the only 2 polar molecules that we had were this one and this one. Lastly, just a few common mistakes to watch out for. Be careful whenever you've gone on to looking at which ones are polar versus nonpolar, because you need to make sure that if there's non-bonding pairs, you treat it as a different domain. And also just be careful that you draw your Lewis dot structure, because without it, there's so many little mistakes that can happen with trying to figure out which one is polar and not. So just don't forget to draw it.